All right, let's find out if an experiment you did can be considered accurate. That means the experiment, the data you received from the experiment is close to what you know is true. It's not far away, it's right on. It's like hit the bullseye kind of thing. The measure for that is called percent error. If you look on the left side of the screen, you should be able to see the percent error formula. So let's do it. You find that the density of an object is 210 kilograms per meter cubed through an experiment. You know the true density should be 235, so you're not right on, but you're wondering if you're considered accurate or not. So, are you accurate? So, we're going to find percent error. So, here's the formula. Percent error equals, and it's going to be a fraction, and it's going to be absolute value on top and absolute value on bottom. That makes sure that we don't have any negatives. So our answer should be positive. So if you end up in the negatives on the top or the bottom, they turn positive because the absolute value bars. So on the bottom is the theoretical value or the true value. So we put this right here, 235. And you may look online and see that as the true value. They may say the theoretical. That's the one that you know is correct. It's not what you did in the experiment. It's somebody has found this before you. It's in a textbook, and you know what it should be. So on the top is going to be your experimental value, right? And this might be an average if you did the experiment several times. It might be the average of all your tests. Here they don't tell us that it's the average. They just tell us they did it once and it was 210. So then you subtract 235, excuse me, and then you multiply it by 100 to get it in percent, okay? So I'm going to do this real quickly on my calculator. You can do it in yours as well. So the absolute value of 210 minus 235 is 25, and then I'm going to divide it by 235, and I will multiply it by 100 to get it in percent, and here's what I get. I get 10.6%. That is my percent error. Now I have a number to go with my experiment, and the determining factor of whether my experiment or the number I get out of this equation is telling me that I'm accurate is whether or not it's less than 20%. So 10.6 is less than 20%. So we are accurate. Nice and easy.